Do you know what I do to people that tell lies?
Extra special thanks to my good friend and colleague Joseph Clemera, links below. Hello all you level-headed flat earthers and sphere-imprisoned globe nutters. We wanted to start from scratch and calculate the amount of curvature expected or necessary on a globe Earth, which we've all come to know and love so well. Easy hip pocket calculations can be used thanks to Dr. Rowbotham, or Parallax, Earth Not a Globe, Zetetic Astronomy, 1865, and plenty of such hip pocket calculations have been done, slightly out of line from the method laid out by Rowbotham, but I'll point that out quickly. When gathering the figures for distances, you must subtract the distance to the apparent horizon from the total distance based on the altitude of the observer. So just to quickly illustrate this, see figure 1. Okay, so you can see the point A is represented by the yellow line of sight, and the yellow area is the apparent horizon for point of view A, while the red line and the red area represents the apparent horizon for point of view B. So as you can see, the apparent horizon is affected by altitude, and anything beyond that horizon point should begin to drop 8 inches per mile squared. So you have to subtract that distance from wherever the observer is standing to the apparent horizon in order to get the calculations correct. So just wanted to point that out really quick for you guys. I'm sure most of you are already aware of it, but it is an easy mistake to make. Okay, so we wanted to verify the accuracy of this equation and take a fresh look at the math in terms of the expected or necessary curvature here on, quote, planet Earth. In order to confirm or test the calculations of Dr. Rowbotham in Zetetic Astronomy using the equation for easy hip pocket calculations of how far an object should drop relative to the distance from any observer standing on a hypothetical, non-existing sphere Earth with a radius of 3959 miles. Now, Joseph Clemera has used a different method to confirm or corroborate or simply test the mathematics of parallax to calculate the expected or necessary curvature held by any body of water across a given distance. Just like skinning a cat, there's more than one way to practice mathematics. The best thing about mathematics is you actually don't have to skin any cats. Personally, I love cats, and I've never actually skinned one, nor can I imagine any good cause to skin a cat, or where that expression even comes from. Probably from a dog person, I would think. Anyways, Joseph did these calculations to demonstrate whether or not Rowbotham was accurate more or less with his calculations, which appears that he was. You can check out Zetetic Astronomy. I've got the full, complete audiobook on my channel if you're interested in learning how Rowbotham came to his equation, 8 inches times the mile squared, to get the ever non-existing yet necessary drop of any object from eye level due to the non-existing curve of the surface of the Earth, or more specifically, the non-existing convexity of the water. Now, you can see in this picture the cliffs of Dover in England, which are viewed with the naked eye from over 20 miles away from Calais, France. This spectacle should be totally impossible on a globe Earth with a circumference of 25,000 miles. However, anyone who's stood at the coast of Calais will know this is a visible phenomenon here on Earth. These images and experiments yet again prove the world to be a plane, not a globe. Our entire worldview or paradigm is based on our observations and intelligent scrutiny of the data we have available. Our entire, quote, infinite space / heliocentric / globe Earth paradigm all hinge on the one minor detail of the world being a spinning sphere. If we were to find the world to be a plane instead of a globe, then we must start from scratch in terms of our understanding of our natural place in the universe. Yet again, we can see with our very own eyes that the waters of the world do not possess even 1 single degree of curvature. The blatant proof we're pointing to here cannot be argued with. Yet people who are very much attached to their seemingly religious belief in a globe Earth will try to argue points of semantics or simply refuse to acknowledge this as evidence of a stationary Earth, which happens to be a plane and not a sphere. They will argue things like refraction, causing the light reflected from the cliffs of Dover over 20 miles up and over an arc of water almost 300 feet tall. With all due respect, we can plainly see that there is not any curvature to this water between England and France, and no amount of bending light will ever trick our eye into rendering a very large, non-existing arc of water as a flat, horizontal plane in our minds. No amount of mental gymnastics or bending of light will ever make this beautiful view possible on a sphere Earth. Refraction can only affect the observer's perception of the true level at a distance, but simply will not make a convex bulge of water appear to be a nearly perfect plane and allow objects obscured by the convex bulge to become somehow visible. Now, just taking a look at figure 2, just wanted to point something out. A degrees declination with the point of curvature being the surface of the world. Error, error. Now these two lines are exactly equal in length and appear apparently equivalent in height for the observer at point A and B, if you make the mistake of considering the center of curvature being upon the surface. On the right-hand side, 8 degrees declination with the point of curvature being the center of the Earth, the lines being equal in length, will have a much greater disparity in apparent height from the observer at A. This is the factor Rowbotham included in his equation as well. This is a mistake commonly made by globe snotters and ball nutters who should love this image a lot due to the fact that there are a couple of balls here. Now, looking at the next image, we've got a summary of the mathematics that Joseph used to figure this up. So R in this diagram represents the distance from the center of the Earth to the circumference or sea level at any point. I should mention that we are looking at a cross-section of the Earth, or in other words, we've cut the globe in half and we're looking at sort of the center of the Earth, not looking at a curve of the Earth when we're doing these calculations. The ground level of an observer is represented by the line at the top. Y equals distance from the point on the center latitude, which is representing the 20.6 miles between Dover and Calais. So, using Euclidean geometry, the problem here is to figure out the distance of S, which is pretty apparent in this diagram, but in order to make this look a little bit more to scale, obviously you're not going to be able to draw this to scale because 20.6 miles scaled down to fit on a screen would be such a small distance you wouldn't be able to even view the problem accurately. So this is sort of an exaggerated representation of the problem. However, it is intended to simply represent the distances in a scaled down version, which is intended to describe the mathematics but is not to scale. Okay, so at any rate, here's the equation. S is going to be the disparity or difference between lines Y and lines R. Now the line R is a known distance. It's the quote radius of the spherical Earth, which is 3,959 miles. We know the distance of X is going to be 20.6 miles. That's the distance between Dover and Calais. So we need to figure out what is the distance from the center equator or a center of curvature represented by line Y. So if S equals R minus Y, which is pretty simple, then Y squared equals R squared minus X squared, and then S equals R minus R squared minus X squared. So we know that R equals 3959 miles, so then R squared, or 3959 squared, equals 15,673,681 miles. X squared, or 20.6 miles squared, equals 424.36 miles. So, R squared minus X squared, or 15,673,681 minus 424.36 equals 15,673,256.64. So that's the miles difference between R squared and X squared. So R minus X equals Y, so Y equals 3958.946405295227. Right. So let's convert this down. R squared minus x squared equals s, or 3959 minus 3958.946405 equals 0.053595, or s equals 0.053595, which represents about 1/20th of a mile times 5280 feet per mile, and that comes to 282.98 feet, say 283 feet of curvature between Dover and Calais. Now,
This corroborates the data that we took at the start of the video. So any dissenters out there telling me that I'm using the incorrect maths, you can shove it up your bumhole, because this is completely correct. Thank you very much.
Now, looking at this image here, we can see plainly the cliffs of Dover from Calais, which is 20.6 miles, obviously a giant bulge of water that sailboat is tugging its way up, right? Or would it be tugging its way down? I guess it would be down, but it's certainly a giant, huge bulge of water there, obviously. Okay, looking at this diagram here, it's a little bit more representative of the, how the distances would look on the actual Earth, but again, the lines R and Y, if we were to represent actually 20 miles on a sphere this small, they would be basically right next to each other, so it's not really plausible to do this to scale. However, the numbers are represented accurately. You can kind of see here we've got R equals 3959, X equals 20.6, and we need to figure out Y, which we've just done in the math just stated. So looking at the next figure, we've got all of the numbers that we need to plug into the equation for the apparent or necessary curvature of the Earth, which is, by all intents and purposes, in accordance with Dr. Rowbotham or Parallax's measurements, meaning he was ultimately correct. And we can indeed use the hip pocket calculations of 8 inches times the mile squared, subtracting the distance to the apparent horizon depending on your altitude above sea level. This is Rowbotham's calculations. 20.6 miles times 20.6 miles equals 424 miles times 8 inches equals 3,200 inches, divided by 12 equals 282.906 feet of curvature. Our calculations got us 283 feet of curvature, and actually I think it was 282.9 something, so almost exactly the same. So to Dr. Rowbotham's equation and 282.9816, according to Joe's method, close enough for me. Way the fuck off for a globe. Earth equals not a globe. Now, to give you a little bit of example of sailboats, they're usually masts are about 30 feet, give or take tall, so that'll give you some idea of how tall the water is not in that example with the schooner visible. Here's a good image of the arc of water, 282.9816 feet tall, question mark. Looks like a flat plane to me. This is another excellent example of the cliffs of Dover being plainly visible and perpendicular to the horizon from over 20 miles away. The water between the 2 points is most certainly a plane and is absolutely not an arc of water with over 280 feet of curvature. The globe Earth is finished. There is no more debate. Game, set, and match for the plane Earth.